Okay, so for your assignment today, we are going to be answering some questions using two-way tables. So for this first problem, we are using the parts performance by age. Okay, and when I look at the two-way table, I notice that they have not given me any totals. So I'm going to go ahead and total the columns and rows to save myself some time later. So the total parts that passed is 5 plus 23. So that's going to give me 28. Okay, the total parts that failed, 2 plus 30, 32. Okay, and so that total is going to be, what is that? 60. Okay. All right, now I'm going to find the total for the new parts, which would be 7. And then the old parts, which would be 23 and 30, which would be 53. Okay, again, when we add the 7 and the 53 together, we get 60. So we're good to go. Okay, so number 1 says, what is the probability that a part chosen at random from this group is new and it passed the test? Okay, so the first thing I want to determine is, what is my denominator going to be? What is my sample? And my sample here is any part chosen at random. So any part chosen at random from the group. So that is going to be the total parts, which is 60. Okay, so they want to know, out of those 60 parts, which were new and passed the test. So it has to fit both categories there. So I'm going to use my little highlighter, and I am going to highlight the new parts, which are here, and also the parts that pass the test here. Okay, so again, it has to fit both categories. So this is where we're looking for the overlap. So 5 parts were new and also passed. So 5 is going to be my numerator. Okay, from here, I am going to reduce my fraction. So that would be 1/12. I'm going to give the decimal, so we're just going to type that in our calculator. 1 divided by 12, which is going to give me 0.0833. Okay, and then I'm also going to give the percent. So when we want to convert from a decimal to a percent, you can either multiply by 100, or you simply just move that decimal 2 spots to the right. So 8.3%. Okay. All right, I'm going to go ahead and erase what I did up at top. Number 2. All right, number 2 says, given that the part is old, what is the probability that the part passed the test? Okay, so if you watched the video from yesterday that had our notes, we talked about how that word given is a really important word. Okay, they are narrowing down the sample for us when they use that word given. So they're telling us we're not looking at the total 60 this time. They're telling us that the part chosen was an old part. So our sample, or our denominator, are only the parts that are old. So we're only looking at this part of the table, only the old parts. So 53, okay, is our denominator. Now our numerator is going to be that the part passed the test. So we want to know how many of these old parts passed the test. Okay, and here's the passed. So again, we're looking for the overlap. 23 old parts passed the test. So 23 is our numerator. Okay, you want to always reduce the fraction if you can, and this time you cannot reduce 23 over 53. Just double check my brain, and that is correct. You cannot reduce it, but we can give the decimal, and we get 0.4339. And then if we want to make that into a percent, we move it 2 spots, and we get 43, and I'm just going to round to the nearest tenth on these, and you get 0.4. All right, last one for this first table. Let's go ahead and erase. Okay. It says, what is the probability that a part is new given that it failed the test? Okay, so there's that word given. Okay, there's our red flag. So given the part failed the test. So those are the only parts that we're focusing on right now. That is our sample. That's our denominator. They had to fail the test. So how many total parts failed the test? 32. So we're only looking at those 32 parts. So of those 32 parts, what is the probability that it's new, that the part is new? Okay, so here is our new parts on the table. Okay, and they had to fail. How many new parts failed the test? 2. So 2 out of the 32. So we reduce that, and we give the decimal, and then we want to give the percent. So that's 1 over 16. Okay, as a decimal, 0.0625. And then as our percent, 6.3. Okay, so that is 1 through 3. Okay, I'm going to do 2 videos for your assignment today, just so the file is not as large and it won't take as long for you to download it. So I'm going to do the front as one video, and then I'll do the back part of your assignment as a separate video for you. Well, crap. If I can get to it. There we go. Okay. So 4 through 6, we're given our table again. They did not total anything for us. So I want to go ahead and find all my totals first. Okay. So total students who watched is going to be 8 plus 9, which will give you 17. Well, I don't like that. That looks ugly. I'm going to redo it. There we go. 17. And then the students who do not watch is going to be 7 plus 16, 23. Okay, and then if we want to find that total here, we're going to add those together. So 17 plus 23 is going to give you 40. So 40 total kids took that survey. Okay, now let's find out how many 9th and 10th graders. So 8 and 7, which is 15. And then how many 11th and 12th graders, 9 and 16, that's 25. And then again, if we add 15 and 25 together, we get 40. Okay, so number 4, what is the probability that a student watches the show given the student is in the 9th or 10th grade? So given is our key word here. Okay, we're given the student that was chosen is a 9th or 10th grader. We know we're only dealing with this part of the table. There are 15 9th or 10th graders who took the survey. So of those 15, they want to know the probability that the student said, yes, we watched the show. So here is watch the show. There's that part of the table, and we want the overlap. Okay, 8 9th or 10th graders said, yes, we watched the show. So 8 is our numerator. 15 is that denominator. Okay, you cannot reduce that. So the decimal, we just plug it in, 0.533. And our percent would be 53.3%. Okay, so a little more than half. Alrighty, number 5. What's the probability that a randomly selected student is in the 11th or 12th grade? Okay, so what is the probability that any randomly selected student that took the survey? So that's going to be out of the total, 40. Okay, any kid who took the survey is our sample. Of those 40, how many were in the 11th or 12th grade? So here is the column for our 11th and 12th graders, and we had 25 total. So 25 out of 40. So if we want to reduce that, you just plug that in our calculator, or you can just use your brain. That's 5 over 8. Okay, and then as a percent, that's going to be, or as a decimal, 0.625. And then as a percent, 62.5%. Okay. All right. Number 6. Number 6 says, given that the student did not watch the show, what's the probability the student is in the 11th or 12th grade? Okay. So given. They're telling you the person chosen did not watch the show. That is your denominator. So how many students did not watch the show? We're looking at this part of the table. Okay, 23 kids said they did not watch the show. So that's our denominator. Of those 23 kids, how many were in the 11th or 12th grade? So again, 11th or 12th grade is going to be this column. Okay, we want the overlap. How many of the kids in the do not watch row were also in the 11th or 12th grade? You're looking for that overlap. So 16. So 16 out of 23. So 16 out of 23 we cannot reduce. But as a decimal, this is what we would get. 0.695 7. Okay, and then as our percent, that would be 69.6%. Boom. All right. So the last example that we're going to talk about before I stop the video is 7 through 9. Again, they weren't very kind. They did not find any totals. So we are going to quickly just total these up. So store A, we are going to add across and we get 18. Okay, store B, again, add across, we get 18. And then to get the total, we add those together and we're going to get 36. And then the males, 12 and 4, 16. And then females, 6 and 14, add those together and we get 20. Okay. Add 16 and 20 and you again should get 36. Okay, so 7. What is the probability that a person chosen from this group is a male who preferred store A? Okay, so what is the probability that any person chosen from the group, so anyone who took the survey, so our sample is 36. Okay, out of those 36, they want males who said that they preferred store A. So it has to fit both categories. A male who preferred A. So we go to our table. Here are the males. Here's everyone who said they preferred store A. And we want the overlap. And I shouldn't have used black, but we're all good. 12. Okay, 12 males said that they preferred store A. So that means that our numerator is 12. So 12 out of 36. Okay, so we want to reduce that, and that's a third. And then our decimal is 0.3333 forever. And that would be 33.3%. Okay. All right, number 8. What is the probability that a person prefers store A? Again, what is the probability that a person, any person who took the survey, so our sample is going to be the total, again, 36 total people took that survey. Of those 36, we want to know how many people said they preferred store A. So here are all the people who said they preferred store A, 18 total people. So 18 out of the 36 said, yes, we prefer store A. And I'm assuming that's probably going to be like Target or something like that. So store A, 18 over 36, we reduce, that's a half, 0.5, 50%. There we go. All right. Number 9. What's the probability that a person prefers store B given that the person was a female? Okay,